Hello, my dear students. Good morning, all of you. Welcome to Kreatryx channel. Welcome to Unacademy and welcome to Impulse Batch. Before going to start the class, let me introduce myself. I'm KV Swami. I did my MTech in Systems and Signal Processing from JNT College of Engineering, Hyderabad, and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching my favorite subjects, signals and systems and communication throughout the country. I have total of 12 plus years of teaching experience and now I'm associated with Unacademy. If you want to purchase any course on Unacademy, you can use my code KVS Live to get flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests are conducted, doubt solving sessions are there, and the importance is batches are conducted in both English and Hindi. Remember, if the student is not comfortable with English, he can take the class in Hindi, and if a student is not comfortable with Hindi, he can take the class in English from his choice of educator. And we have rank improvement batches also. Apart from this, we have one more type of subscription known as Iconic subscription, in which the student will be under the supervision of a educator known as mentor. So a coach is given to the students here, study planner is given, study booster sessions are there, test analysis is there, doubt clearing instructors are there, and study material, preparatory study material also given. Now, if we observe, and one more thing is, remember my dear students, that here let me change the date, 28th March. See, Unacademy is coming with a new initiative known as Unacademy Combat, which is an online exam which will be held for 1 hour duration, 60 minutes, and the branches eligible are electrical and ECE. And if you're able to get in the top 3 positions, you'll get the Plus subscription at free of cost. So top 3 winners in each branch, from each branch, get 100% scholarship on Plus subscription. So in order to write this exam, you can use my code KVS Live. KVS Live. This is also about the Unacademy Combat. 28th March, that is on Sunday, 11 AM. You can unlock this using the code KVS Live. This is also Unacademy Combat. Fine. If you observe, what are the, good morning Bharat, what are the various fee structures for GATE in Unacademy? In Plus subscription, if a student is planning for GATE or ESE preparation in Plus, for 12 months, that is 1 year, it costs around 27,225 rupees only using the code KVS Live. In Plus subscription, GATE or ESE preparation for 18 months, that is 1.5 year course, it costs around 34,650 using the code KVS Live. In Plus subscription, GATE or ESE preparation for 24 months, that is 2 years program, it costs around 39,600 using the code KVS Live. Coming to Iconic subscription, so GATE or ESE preparation in Iconic subscription, that is under the supervision of a mentor, for 12 months, that is 1 year, it costs around 45,225 rupees only using the code KVS Live. Again, in Iconic subscription, GATE or ESE preparation for 24 months, that is 2 year program, it costs around 66,600 using the code KVS Live. So whatever may be the subscription, either Plus or Iconic, feel free to use my code KVS Live. KVS Live. Right. Let's switch back to our topic. So those who are coming new, please subscribe the channel and share the session. Subscribe the channel, those who are coming new, and share the session. And I'm observing very less number of students today. Okay, let's start the class. See, in the last class, if we do a recap, what we were discussing, we were discussing energy signals and power signals. What is the purpose of finding energy and power? They are used to measure the size of a signal. Right. Now, in the last class, what we were discussing? We were discussing about the power calculation. Suppose for a periodic signal, suppose if you are given a periodic signal, how to find out the average power over a period? Calculate the energy. Over the period, calculate the energy. And we have done so many examples based on this. Hope you remember all those examples. Suppose as a repetition, as a continuation, suppose if I ask you, if I have a periodic signal like this, x of t, can you tell me what is the average power here? Can you tell me what is the average power? What is the average power? Come on, type your answers, my dear students. I want the average power of this periodic signal. This is a periodic signal. Periodic signal given means what I told you. First of all, we must identify the period. So what is the period here? Period is t, because the shape at 0 is repeating at t. Now, over the period, so you take from 0 to t or minus t by 2 to t by 2. Now, whatever the signal is present in the period, for that calculate the energy. What is the signal present? Here we have this kind of sinusoid. And what is the energy for this one? Already I told you in the previous classes that if you are having this kind of signal, a square t by 2. So what will happen here? A square alpha by 2. Right? In this way you can calculate. A square alpha by 2 over the period you calculate the energy and take the ratio. Exactly. Right? And after this, suppose if x of t is equal to a, what is the average power? We got a square. If x of t is equal to a u of t, what is the average power we got? A square by 2. Hope you remember. Hope you remember this one. Suppose if I ask you, what is the average power in the signal x of n is equal to a? X of n is equal to a. Discrete time signal. Now how you are going to plot this one? X of t is equal to a in continuous means you are going to plot like this. X of n is equal to a means what? discrete time signal. Now, how to find out the average power? Or you do one thing, better you get confusion here. Anyway, we are going to discuss in periodic and aperiodic signals. You take AU of n, AU of n. P average is equal to, this is not a periodic signal. Limit will come, limit n tends to infinite, 1 by 2n plus 1 summation n varying from minus n to n magnitude of x of n whole square, right? So P average is equal to limit n tends to infinite 1 by 2n plus 1, but here the signal is existing from 0, no? So 0 to n you take magnitude of x of n whole square, a square, or average power is equal to a square times, if I a square times limit n tends to infinite 1 by 2n plus 1 summation n varying from 0 to n will come here 1. Always remember, if you are having a summation, lower limit is there, upper limit is there, a constant is there. Now you can simplify this summation as constant times upper limit minus lower limit plus 1. We have summation, lower limit, upper limit, a constant is there. This is nothing but constant times upper limit minus lower limit plus 1. This is a square, limit n tends to infinite 1 by 2n plus 1, upper limit minus lower limit plus 1, or a square times limit n tends to infinite 1 by 2n plus 1 n plus 1, or you can simplify this as a square limit n tends to infinite, take n common, 1 plus 1 by n by take n common, 2 plus 1 by n. Here n gets cancelled, and we know that as n tends to infinite, 1 by n tends to 0, or average power will be a square by 2. This will be the answer, a square by 2. Or directly from here also you can write, whenever you have limit n tends to infinite, you can take the highest order coefficient in the numerator by highest order coefficient in the denominator, right? Directly a square by 2, directly you can write. Anyway, we are going to summarize all this in the revision session. AU of n is the signal I took. First of all, I have written the expression. This is an aperiodic signal, so limit will come. Okay, after this, if I take one more signal, x of t is equal to a e power j omega naught t. A e power j omega naught t. Remember students, this signal has the name complex exponential. Remember, e power j omega naught t, the name of this signal is complex exponential, and this is a periodic signal. Periodic signal. How to find out the fundamental period? Anyway, we are going to discuss in the next part. Periodic and aperiodic signals. So, if I want to find out the average power, so periodic signal means average power. What is the expression? 1 by t integral minus t by 2 to t by 2. Limit will not come. Limit t tends to infinite will not come. Magnitude of x of t whole square dt. This is 1 by t integral minus t by 2 to t by 2. What happens if I take the magnitude e power j omega naught t, means it can be written as cos omega naught t plus j sin omega naught t. So if I take the magnitude and if I square it, what will come? A square dt. This is a square by t a square by t. Integral of dt is t between minus t by 2 to t by 2, or a square by t a square. This will be your answer. Hope you're all getting. See, after this, a previous question was asked like this in GATE exam. Simple question. He asked the question like this. He said, if the average power in the signal g of t is Pg, then average power in the signal ag of t, where a is a constant, is how much? Come on, type your answers. Average power in the signal g of t is Pg, he said, and is asking us to find out the average power in the signal ag of t. ag of t. ag of t. ag of t. What could be the answer, my dear students? G of t Pg. What is the average power in the signal ag of t? Very simple. So much time you are taking. What is your answer? G of t signal average power is Pg, then what is the average power in the signal ag of t? Right. Yes, it is a square multiplied with p. So the answer is a square multiplied with Pg. Or if you have any doubt, you can prove also. So what is said, average power in the signal g of t is Pg. Pg is what? Average power. So limit t tends to infinite, considering to be a periodic signal, 1 by t integral minus t to minus t by 2 t by 2 g square of t dt. Average power in g of t. Now average power in ag of t is we don't know. Let it be some pg dash. So limit t tends to infinite 1 by t integral minus t by 2 to minus t by 2 to t by 2 a square into g square of t dt. I can write like this. So I'm assuming the signal to be real. So magnitude square will be the square of the signal. So what will happen? Bring a square outside. If you want the proof, minus t by 2 to t by 2 g square of t dt. But what is this equal to? This is equal to pg, no? Right? Implies pg dash is equal to a square times pg. Right? What happens if a is minus 1? See, g of t pg minus g of t is also pg, means with amplitude reversal also average power is not going to change. With amplitude reversal also average power is not going to change. So we can summarize like this. Average power, see, if you if you differentiate between energy and time, energy does not change with what energy does not change with time shifting. Energy does not change with time shifting, my dear students. Second one, time reversal, it will not change. Energy I am talking about. Time reversal, it will not change. Amplitude reversal, it will not change. Very, very important point. Make a note. Energy does not change with time shifting, time reversal and amplitude reversal. But with the time scaling, energy changes. Next, average power does not change with in the last class we have seen, does not change with time shifting. Time shifting, average power will not change. Time scaling also. Average power will not change. Time reversal also. Average power will not change. Just now we have seen amplitude reversal. Amplitude reversal also, average power will not change. Change in frequency. See, if there is a change in the period, definitely there is a change in the frequency of a periodic signal, which is a power signal. Change in frequency and change in phase also. Change in phase also. Suppose if I take x of t is equal to a sin omega naught t, its average power will be a square by 2, RMS square. A square by 2 will come. If I take x of t is equal to some a sin 3 omega naught t. Here frequency is omega naught, here frequency became 3 omega naught. In this case also a square by 2. So it does not change with frequency. Suppose a sin omega naught t plus phi. In this case also average power is a square by 2 only, my dear students. Remember, very, very important discussion. Important discussion. Energy does not change with what? Time shifting, time reversal, amplitude reversal. Average power, time shifting, time scaling, time reversal, amplitude reversal, change in frequency, change in phase also. The first two already we have seen in the last class. Okay, this scale reversal is nothing but a special case of scaling. This you can verify. Amplitude reversal just now we have seen, change in frequency and change in phase. Fine. After this, look here. The next important discussion in this energy and power signals only is average power. Very, very important topic. Listen carefully. Average power for linear combination of sinusoids. Average power for linear combination of sinusoids. Observe here, sir. Suppose your signal is like this. X of t is equal to a1 sine omega 1t plus phi 1 plus a2 sine omega 2t plus phi 2. Suppose if you are given a signal like this and you are asked to find out the total average power. So how to find out? I'm not going to the proof. Proof you can take it as homework. Average power is nothing but a1 square by 2 plus a2 square by 2. Means you can add the average powers of the individual sinusoids provided if omega 1 not equal to omega 2. If this omega 1 and omega 2 are not equal, you can simply add the average powers of the individual sinusoids. And this becomes, average power becomes a1 square by 2 plus a2 square by 2 plus a1 a2 cos of phi 1 minus phi 2. When you have to do this, if omega 1 is equal to omega 2, if they have same frequency, and phi 1 minus phi 2 not equal to n pi by 2. N pi by 2. So if you are given two sine signals, you can add their powers if they have different frequencies. If they have same frequencies and the difference between the phases is not equal to a multiple of pi by 2, then you have to go with the second expression. Second expression, right? For example, look at, sir, can you tell me with an example? Yes, I can tell you with an example. X of t is equal to 6 sine 10 pi t plus 4 sine plus 4 sine 6 pi t. Suppose if I have a signal like this, so what happens to the power? What happens to the total average power? Now if you observe here, what is omega 1? Omega 1 is 10 pi, and what is omega 2? 6 pi. So omega 1 not equal to omega 2. Omega 1 not equal to omega 2 means what? Simply add the powers of the individual signal. So it is nothing but 6 square by 2 plus 4 square by 2. 6 square by 2 plus 4 square by 2. Suppose if I have situation like this, x of t is equal to 6 sine 10 pi t plus 60 plus 4 sine 10 pi t plus 30. Now what happens to the total average power? Now here observe, two signs are there. Two signs means first of all we must observe whether the frequencies are same or not. If they are not same, simply add the powers. Now if you observe, omega 1 is 10 pi and omega 2 is also 10 pi. Then what is the total average power? If omega 1 and omega 2 are equal, and this phi 1 and phi 2, if you take the difference, it is not equal to 90 degrees. Yes or no? So you have to go with the second expression. What is that? A1 square by 2 plus A2 square by 2 plus A1 A2 cos of phi 1 minus phi 2. It's as simple as that. So A1 square by 2 plus A2 square by 2 plus A1 A2. A1 A2 means 24 cos of 30 degrees. Phi 1 minus phi 2. You can simplify this one. You'll get the answer. You can simplify this one. Not a big issue. So this is the case when you are given two sine signals. Right? Now, what happens if you are given two cos signals? Observe here, students. X of t is equal to, suppose if your signal is like this, A1, very, very important concept, omega 1t plus phi 1 plus A2 cos omega 2t plus phi 2. So here average power will be A1 square by 2 plus A2 square by 2. Same concept as in the case of sine. If omega 1 not equal to omega 2 and it is equal to A1 square by 2 plus A2 square by 2 plus A1 A2 cos of phi 1 minus phi 2. If omega 1 is equal to omega 2, means if frequencies are same and the difference between phases phi 1 minus phi 2 not equal to n pi by 2. Same concept. Here simply I am replacing sine with cos. The same thing holds good. Always remember one statement I want to say, that if you are adding the powers of the individual signals, means those signals are orthogonal, then only we can add the powers. One term is there is one concept called orthogonality, which we'll be discussing later. See, if two signals are energy signals and if they are orthogonal, you can simply add their energies. And if two signals are power signals and if they are orthogonal, you can simply add their powers. Here, if I'm adding here means what? For if omega 1 not equal to omega 2 means these two signals must be orthogonal. Right. There is a separate topic called orthogonality, which we'll discuss in detail later. Fine. Suppose this is second case. Third case is, suppose if I have a situation like this. X of t is equal to some A naught plus A1 sine omega t plus phi or A naught plus A1 cos omega t plus phi. Now first one is a DC signal, second one is a sinusoid. And remember, if you want to find out the average power, simply add. For these two cases, simply add the powers. Means what? DC and sinusoid are always orthogonal. P average is equal to A naught square plus A1 square by 2. Suppose if I have an example like this. Example. X of t is equal to 2 plus 3 cos 4t plus 60. Something is there like. Now what is the average power? DC is their sinusoid, means you can simply add their powers. DC means what is the average power? DC square, no? So DC square plus here this one RMS square, 3 by root 2 whole square or 3 square. This is 4 plus 9 by 2. A DC is there, a sinusoid is there, means you can simply add the powers. Okay. Next one. Suppose if I have this kind of one sine, one cos is there. X of t is A1 sine of omega 1t plus phi 1 plus A2 cos, not so. A2 cos of omega 2t plus phi 2. Suppose this is a situation. One sine signal, one cos signal. Now what is the average power? Average power is nothing but A1 square by 2 plus A2 square by 2. If omega 1 not equal to omega 2, or if omega 1 is equal to omega 2 and phi 1 is equal to phi 2. Suppose if you have one sine signal and one cos signal, when you can add their powers? If they have different frequencies, or you can add the powers if they have same frequencies and same phases also. Same frequencies and same phases also. Suppose if I take an example like this. X of t is equal to 6 sine 10 pi t plus 60 degrees plus 4 cos 6 pi t plus 30 degrees. Suppose if I have a situation like this, observe my dear students. See here, one sine is there, one cos is there. Means when you can add the powers, you can add the powers if they have different frequencies. So here different frequencies, omega 1 is 10 pi, omega 2 is 6 pi. Yes, you can add the powers. So P average is equal to 6 square by 2 plus 4 square by 2. Suppose if you have situation like this, X of t is equal to 6 sine 10 pi t plus 60 degrees plus 4 cos 10 pi t plus 60 degrees. So sine and cos are there, but if you observe frequencies, omega 1 is 10 pi, omega 2 is also 10 pi, phi 1 is 60, phi 2 is also 60. So frequencies are same, phases are also same, means again you can add the powers. You can add the powers 6 square by 2 plus 4 square by 2 you can write. Suppose if you have a situation like this, and students observe, this is an important one. xt is equal to 6 cos 10 pi t plus 4 sin Suppose if I have a situation like this, look here, cos and sin are there, look here, cos and sin are there. Now I have to find out the total average power. Now I can add when if I have cos and sin, when I can add, if the frequency, first case is what here, if the frequencies are different. No, here frequencies are same. Or you can add the powers if frequencies are same, phases are also same. Here if you observe, frequencies are same but phases are not same. This is a different situation. See, one cos is there, one sin is there, means what? You can add the powers if they have different frequencies. No, here they have same frequencies. Again you can add the power if they have same frequencies and same phases. Here if you observe, sequences are same, phases are different. Now in this case, how to find out the average power means, do one thing, convert these two terms into cos or sin, then you will have a solution. What I am saying is convert these two terms into either cos terms or sin terms, and we know that cos omega t, how I can write? Can I write like this? Sin omega t plus 90 degrees. Yes or no? Yes or no? Yes. So what I am going to do is 6 sin 10 pi t plus 90 degrees I can write, plus 4 sin isn't it? Can I write like this? Tell me yes or no. Nobody is replying. Nobody is replying. Can I write like this? Yes or no? Right. Now I got the situation now. If now I have two sines with same frequency, different phases. Observe here. Do you have that situation? Look here. I have two sines with same frequencies, different phases, and phi 1 minus phi 2 not equal to n pi by 2, means a1 square by 2 plus a2 square by 2 plus a1 a2 cos of phi 1 minus phi 2. Right. Now how I can simplify this one? Average power is equal to a1 square by 2. See, this is omega 1, this is phi 1, omega 2, phi 2. So a1 square by 2 plus a2 square by 2 plus a1 a2, 24 cos of phi 1 minus phi 2. You can simplify this one, not a big issue. Hope you're all getting this one. See, if a cos and a sin is given, you can add the powers if they have different frequencies, and if they have same frequencies and same phases only, you can add the powers. Here frequencies are same but phases are different, so we don't have any expression like this. So what we have to do? We have to convert both into cos or both into sin in that situation and use the available concepts. Okay, now you can solve this one, not a big issue. So these are very, very important expressions, my dear students. power calculations for linear combination of sinusoids. So again, I'm repeating for the sake of convenience. Look here, average power for linear combination of sinusoids is the topic. Suppose if you have two sine signals, A1 sin omega 1t plus phi 1, A2 sin omega 2t plus phi 2. Now, the total average power will be, you can add the individual average powers if they have different frequencies. And the average power becomes A1 square by 2 plus A2 square by 2 plus A1, A2 cos of phi 1 minus phi 2 if they have same frequencies and different phases, and the difference of their phases phi 1 minus phi 2 not equal to n pi by 2. So examples we are seeing. 2 cos, same principle holds good. Suppose if I have a DC and a sinusoid, means simply you can add the individual powers. DC and sinusoid. I'm adding the individual powers means, remember in technically we are going to say that DC and sinusoid are orthogonal. Suppose if I have one sine signal, one cos signal. So you can add their individual powers if they have different frequencies or if they have same frequencies and same phases. So we have seen all the possible cases. Right. Fine. This is all about your energy signals and power signals. Now let's turn our attention to the next classification of signals known as periodic and aperiodic signals. So the next classification of signals, what we are going to discuss is everything will be revised. I'm planning a marathon session so that we can revise each and every topic in the first unit. That is starting from the definition of a signal. What is an independent variable? What are the transformations of the independent variable like shifting, reversal and scaling? What happens if you are given shifting and scaling? What are the available methods for continuous as well as discrete? What are the basic signals? What are their properties? And what is the classification of signals? Each and every point we are going to discuss in the form of a marathon. But for that kind of session, you must have a patience, because I'll be writing each and every point on the board and I'll be sharing the PDF to you. Right. So these concepts we are discussed now, everything, all these concepts. See, energy does not change with what, average power does not change with what will happen. Okay. So all the concepts we are going to write on the board and I'll share the PDF with you so that it will become a short notes for the first unit. What is an impulse signal? What is a doublet signal? Okay. What is the relation? Areas, RMS values, average powers, all we are going to write. Don't worry. Now the next classification of signals is periodic signals, aperiodic or non-periodic signals. Aperiodic or non-periodic signals. Periodic signals means, the definition is signals which repeat at regular intervals of time. Signals which repeat at regular intervals of time. Repeat at regular intervals of time. Regular intervals of time. Aperiodic or non-periodic signals means signals which won't repeat at regular intervals of time. This aperiodic signal does not repeat at regular intervals of time. And this is the definition. Definition: periodic signal means signals which repeat at regular intervals of time. Aperiodic or non-periodic signals means they won't repeat at regular intervals of time. Or we can put in terms of expression also. Suppose if I take a continuous time signal, a continuous time signal is said to be periodic if it satisfies the property x of t is equal to x of t plus or minus mt. t plus or minus mt. Signals which doesn't satisfy this property, t plus or minus mt, they are said to be aperiodic or non-periodic signals. Remember students, here m is a integer, m is a integer and t is known as fundamental period. T is known as fundamental time period. Fundamental time period. For example, look here, we can show, if I take a signal like this, observe here. If I take the first signal x of t, whatever the shape I am having at 0, same shape is repeated at t. What is the shape I am having at 0? Same shape is repeated at 2t. What is the shape I am having at 0? Same shape is repeated at minus t also. Or we can say that this is a periodic signal. Or for this signal you apply this expression. For this signal you apply this expression for different values of m, for different integer values of m. Either you delay or advance by taking different value integer values of m, you are going to get the same signal x of t. So this is an example for periodic signal. Now if you observe this one, this is not a periodic signal because the second signal is not repeating. It's not repeating. Or you apply this expression for this signal, it will not be satisfied, right? Here, what is the fundamental period? Fundamental period is the minimum value of t, minimum positive value of t for which the signal is repeating. Here t is the fundamental period. T is the fundamental period. And remember, this fundamental period t not equal to 0 and t not equal to infinite also. Fundamental period not equal to 0 and not equal to infinite. T should not be equal to 0 and t should not be equal to infinite. And t must be positive. Positive. Here you observe in the given signal x of t, what is the minimum value of the period for which the signal is repeating? T, capital T. So here capital T is known as fundamental period. Fundamental period, right? Now, one important point I want to say, we have seen the definitions of periodic signals and aperiodic signals. Periodic signals means they repeat at regular intervals of time. Aperiodic signal means they won't repeat at regular intervals of time. In terms of expression, a periodic signal can be given like this: x of t is equal to x of t plus or minus mt, where m is an integer. So take this kind of periodic signal and give different values of m, integer values, and see whether this expression is satisfied or not. Yes, it will be satisfied. So here capital T is known as fundamental period. Fundamental period is the minimum value of the period for which the signal is repeating itself. And fundamental period is a positive value and its value is not equal to 0 and not equal to infinite. And one more point I want to say regarding periodic signals, that periodic signals starting point must be minus infinite. Periodic signal means it should start at minus infinite and it must end at plus infinite. See, or I can say that periodic signals are, very, very important point, periodic signals are everlasting signals, will say. Everlasting means they exist from minus infinite to plus infinite. Everlasting signals, periodic signals are everlasting signals existing from minus infinite to plus infinite. minus infinite to plus infinite. Periodic signal means it should not start at 0 and end at infinite, but a periodic signal means it starting point must be minus infinite and ending point must be plus infinite. So we say that they are everlasting signals existing from minus infinite to plus infinite. That is the next point. Now, by looking at the example what I gave here, can I say that all periodic signals are power signals? All periodic signals are power signals because they are going to maintain a constant amplitude throughout the interval. But the converse is not true. All power signals are not periodic signals. So here we can say, or I can write, all periodic signals are what? Power signals. But all power signals are not periodic signals. All periodic signals are power signals, but all power signals are not periodic signals. Right? Now, after this concept is done, now observe here. One more interesting point I want to reveal. Here, first signal I have taken x of t. What is the period here? My dear students, what is the period? Period is t. Period is t. Now, what I want to do is, I want to increase the period. Look here, in the periodic signal, look here, my dear students, observe carefully. In the periodic signal, I want to increase the period. Can I say that increasing the period is equivalent to increasing this distance? What I'm saying, in this periodic signal x of t, I want to increase the period, which is nothing but increasing this distance, and increasing this distance is equivalent to moving the components, these components and these components. Yes or no? Moving the components aside. Look here, if I want to increase the period means increase this distance. Definitely your period increases. Still I want to increase the period. Do one thing, still increase the distance. Still increase the distance. So here, if I increase the period, what will happen? This separation, this increases, no? Increases because I am increasing the period. Now, as a limiting case, observe, as a limiting case, what I want to do is, I want to make this period t tend to infinite. I want to make this period t tend to infinite. What happens if I make this period t as infinite? Means after the first part, look here, after the first part, this second part will exist at what? Infinite. This one also, left side, this also will exist at minus infinite. Means in that case, what will happen? I am left with a periodic signal, no? What happens if I make this period t tend to infinite? What happens if I make this period t tend to infinite? I am left with a aperiodic signal like this. Yes or no? Or an aperiodic signal can also be considered as a periodic signal with period t is equal to infinite. Remember, my students, important statement. An aperiodic signal like this, look here, can also be considered as a periodic signal with period t is equal to infinite. We can consider that this aperiodic signal is also repeating. See, periodic signal means what? Repetition is required. So we can say that for this aperiodic signal also repetition is there, but where it is repeating? At t is equal to infinite. Okay, or we can say that an aperiodic signal can also be considered as a periodic signal with period t is equal to infinite, from which the concept of Fourier series and Fourier transform were developed. Fourier series is calculated for periodic signals, and Fourier transform is calculated for aperiodic signals based on the assumption that an aperiodic signal is also a periodic signal with period t is equal to infinite. Remember, we can consider an aperiodic signal as a periodic signal with period t is equal to infinite. Now, simple explanation I can give you. Look here. See, energy signals and power signals we studied, no? Look here. X of t, observe here, my dear students. X of t is equal to e power minus 2t u of t is there. Or this kind of signal, suppose if I have. Suppose if I have this kind of signal, my dear students, x of t, some signal is there. Alright. Now, if I ask you one question, what is the energy in this signal? What is the energy in this signal x of t? Energy, can you tell me what is the energy? What is the energy? What is the energy? Come on, what is the energy in this signal? Rectangle means what? A square t, no? So a square means 1, t means 2. So energy is 2. Now what is the average power? What is the average power? 0. Energy is 2, average power is 0. Now look here. First observe here. Now if I ask you now, this is a periodic signal or aperiodic signal? This is a periodic signal or aperiodic signal? Periodic means repetition must be there at regular intervals of time. Aperiodic means repetition should not be there. This is periodic signal or aperiodic signal? This is a aperiodic signal. Aperiodic signal because this is not repeating. Now, what I said, an aperiodic signal can also be considered as a periodic signal with period t is equal to infinite. I said, yes or no? Now, we have seen average power. Look here, average power for a periodic signal is what? Average power for a periodic signal. Average power for a periodic signal is over the period, over the time period. Calculate the energy I said, no? Calculate the energy I said. Now, this is a periodic signal. This can also be considered as a periodic signal with period t is equal to infinite, and calculate the energy. Energy is what? Within the period, what is energy? 2. So something by infinite is what? 0. So in this way also you can prove. Yes or no? If you don't understand also, no issues. My intention is that an aperiodic signal can also be considered as a periodic signal with period t is equal to infinite. So one aperiodic signal I took here, energy I calculated, and we know that average power for energy signal is always 0. So average power for a periodic signal. Over the period, calculate the energy. Whatever the signal is present, for that calculate the energy. This is the signal present. In this way also you can get the average power as 0. Okay, fine. Okay, if you don't understand also, no issues, my dear students. If you understand the definitions of periodic signals and aperiodic signals, that is enough. Fine. Now, how to find out the fundamental period of a continuous time signal is the question now. So the next discussion is fundamental period, fundamental time period of a continuous time signal. Continuous time signal. Now the story starts. Interesting story, important story starts. Fundamental period of a continuous time signal. Suppose if you are given signals of this form, A sin omega naught t, A cos omega naught t. First signal you know, second signal you know. Some e power j omega naught t. This signal, third signal, already I told you, this is known as complex exponential. What is the name for this one? Complex exponential. So if you are given these kind of signals in continuous, let me write, these are always periodic. Always periodic with fundamental period t is equal to 2 pi by omega naught. Remember, my dear students, continuous time sinusoids and complex exponentials. Continuous time sinusoids and complex exponentials are always periodic with the fundamental period t is equal to 2 pi by omega naught. Here, omega naught is known as the fundamental frequency angular frequency measured in radians per second. Measured in radians per second. If you're given continuous time sinusoid or a complex exponential, first observation is they are always periodic. They are always periodic. Then how to, if periodic, the next task comes is how to find out the fundamental period. Simply use the expression t is equal to 2 pi by omega naught. 2 pi by omega naught. Right? Continuous time sinusoids and complex exponentials are always periodic. For example, look here. X of t is equal to cos 60 pi t. Cos 60 pi t. This is a signal what I am having. Now I want to find out the fundamental period. I want to find out the fundamental period. Now first observation is what? This is continuous time sinusoid. This is always periodic. And how to find out the fundamental period? T is equal to 2 pi by omega naught. Write the expression. What is then in place of omega naught? Two pi by 60 pi. 1 by 30 seconds. 1 by 30 seconds. Right? You can verify also. Periodic signal means it must satisfy this, no? So let's calculate x of t plus 1 by 30 cos of 60 pi. Wherever you have t, substitute t plus 1 by 30. Yes, we are going to get this one. Right? Suppose if you are given x of t is equal to e power j phi t. E power j phi t. What is the fundamental period, my dear students? Now, first of all, this is a complex exponential. What is the in place of omega naught? 5. So, fundamental period t is equal to 2 pi by omega naught. Okay. Suppose if I give you this one. Sin 3 pi t u of t. Sin 3 pi t u of t. What is the fundamental period? Tell me. What is the fundamental period? Sin 3 pi t u of t. Come on, type your answer. Sin 3 pi t u of t. What is the fundamental period? Arey, what happened? Nobody is replying. I am not observing any heat in the chat box. Manu, not periodic. Okay. Manu, I think you are asking the question in the last class without scaling property. You got the answer? I told you to use gamma function. See. Yes. Sin 3 pi t means what is the shape? Sin 3 pi t means this kind of shape will come. U of t means what is the shape? This shape will come. Multiplication, and we know that multiplication of signals is nothing but multiplying at common points. So if you multiply, what will happen? This kind of signal will come. But we know that for a signal to be periodic, it must be everlasting, existing from minus infinite to plus infinite. I told you, no, periodic signal means they are everlasting signals. But the signal exists from 0 to infinite, which makes this signal as a periodic signal. or non-periodic signal? Aperiodic signal or non-periodic signal? Suppose if I ask you for this one, xt is equal to EV of cos 4 pi t u of t. I want the fundamental period for this one, where EV stands for even part. EV of cos 4 pi t u of t I want, fundamental period. And we know how to find out the even part of any signal. Signal plus its reversal by 2, right? I want the fundamental period. So cos 4 pi t u of t signal plus its reversal cos 4 pi minus t u of minus t signal plus its reversal by 2. So here what will happen? Cos is an even function, no? So cos 4 pi t, take u of cos 4 pi t common, u of t plus u of minus t by 2. But what is u of t plus u of minus t? From our earlier discussions, it is nothing but a constant or DC signal 1, or this is 1 by 2 cos 4 pi t, which is an everlasting signal existing from minus infinite to plus infinite. How to find out the fundamental period? 2 pi by 4 pi, 1 by 2 seconds. Homework is xt is equal to even part of sine 4 pi t u of t. Homework is xt is equal to even part of sine 4 pi t u of t. Right. After this, if I ask you one question, what is the fundamental period for this one cos 2 pi t? What is the fundamental period for cos 2 pi t? It is 1 second. Yes or no? Cos 2 pi t, 2 pi by 2 pi. Now, what happens if I add a DC signal or a constant? Remember one important point, that fundamental period of this DC or constant is not defined. Fundamental period of DC or constant is not defined. But if you are going to add this kind of DC to any sinusoid, it doesn't affect the fundamental period. Or I can say that adding or subtracting a DC signal to any periodic signal doesn't affect the fundamental period. Adding or subtracting a DC to a periodic signal doesn't affect the fundamental period. Means if you have DC, you can simply ignore. You can simply ignore. Okay, so let me write that point. Note. So adding or subtracting a DC to any periodic signal doesn't affect the fundamental period. Doesn't affect the fundamental period. Doesn't affect the fundamental period. Suppose while looking at this kind of statement, generally I said I gave you some signal and I told this kind of analysis. No, You may be having a doubt that why can't I check with another kind of periodic signal? Means you can check. Observe here. Do one thing. Take this kind of periodic signal. You can always experiment. Say this is a periodic signal I am having. X of t. Say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is -1, this is -2, -3, -4, -5, this is half, this is -half, right? Now can you tell me what is the period? Fatafat, can you tell me what is the period? Period means what? Repetition. Period means repetition. What is the period? Come on, tell me what is the period, my dear students? What is the period here? Shape at 0 is repeating at what? So period is 4. Now add one DC. So what happens if I add a DC? Constant x of t plus 1 by 2. I want to add a signal, a constant 1 by 2 to this one. So first of all, 1 by 2, how it will look like? So what I want to do is I want to add x of t plus, I want to perform x of t plus 1 by 2. First of all, draw 1 by 2. 1 by 2 means constant like this. Okay, DC. Already we know how to draw this one. Now, just now I got an idea, just I'm experimenting. -1, 0, 1, 2, 3, 4, 5. Here -2 will come. Right. Try to add these two signals. Try to add these two signals and observe what happens. From -1 to 1, observe here, student. From -1 to 1, this value is 1 by 2. This value is also 1 by 2. 1 by 2 plus 1 by 2, 1. You know how to add two signals. Now from 1 to 3, this value is -half, this value is +half. So 0. Again from 3 to 5, this value is 1 by 2, this value is half. 1 by 2 plus 1 by 2, 1. And so on. Same here. What is this signal? This signal is nothing but x of t plus half. Now, what is the period here? Period means repetition. Observe. Shape at 0 is repeating at 4. So if you add any DC to any periodic signal, the period will not change. The period is not going to change. Isn't it? Yes or no? Right. Now I can make one statement here that, look here, after this example is completed, fundamental note, this one also note, important point. Fundamental period of a periodic signal will not change. Do you have any idea? In which cases it will not change? In the earlier classes, if you observe, last class, if you observe, I told you period, fundamental period of a periodic signal, it will not change with time shifting. Time shifting, it will not change. Time shifting. Time reversal, it will not change. Time scaling, with the time scaling, fundamental period changes. Time scaling, fundamental period changes, my dear students. Time scaling, fundamental period changes. And third one, what you can write? What you can write? Just now we have seen. So period is not changing. What is this operation known as? Can I write it as amplitude shifting? Can I say this as amplitude shifting? Yes. Time fundamental period of a periodic signal will not change with amplitude shifting. And it will not change with amplitude reversal also. Amplitude reversal also it will not change. And it will not change with phase also. Change in phase. Change in phase. Right? So fundamental period, remember my dear students, it will not change with time shifting. If you perform time reversal, amplitude shifting, amplitude reversal, change in phase. Change in phase means, look here, x of t is equal to a sin omega naught t. T is equal to 2 pi by omega naught. X of t is equal to a sin omega naught t plus pi by 4. For this also t is equal to 2 pi by omega naught. With change in phase, fundamental period is not going to change. Fine. Yes, yes. Observe here. Now I have a question for you. First of all, what we have seen, my dear students, we have seen how to find out the fundamental period. Suppose if your signal is in the form of a sin omega naught t, a cos omega naught t, or e power j omega naught t, you can simply find out the fundamental period by using the expression t is equal to 2 pi by omega naught. Now my question is, I have a question for you. You have to answer. Listen carefully. Listen carefully. What I am saying is that I have a periodic signal. But I cannot represent that periodic signals in sinusoids or complex exponentials. Then how to find out the fundamental period? Again, I am saying I have a periodic signal. A periodic signal is given to you, but that is not in the form of sinusoids or complex exponentials. Still, you need to find out the fundamental period. Then how you are going to do that? Can you type your answer? Can you type your answer in the chat box? My question is, other than a sinusoid or a complex exponential, if you are given other periodic signal, how to find out the fundamental period? Sinusoid or complex exponential is given, a ready-made expression is there, t is equal to 2 pi by omega naught. 2 pi by omega naught. Suppose if I am given a signal which is not in the form of sinusoids or complex exponentials, how to find out the fundamental period is my question. Ending point minus starting point is equal to width. Manu, repetition time from graph. Exactly what Manu has said is right. See, when you are unable to express your signal in sinusoids or complex exponentials, the only alternative is to draw the signal. Right? Suppose if you are given a signal like this, my dear students. If you are given a signal like this, summation n varying from minus infinite to infinite, del of t minus n, some signal is given. Some signal is given to you. And you're asked to find out the fundamental period. Now, if you observe, this is not in the sinusoidal form or this is not in the complex exponential form. Then how to find out the fundamental period? To draw the signal. How to draw the signal? Give different values of n here. So whenever you're having summation, you have to give different integer values. This is a continuous time signal, independent variable is t. What happens if I substitute n is equal to 0? Del t. N is equal to 1, del t minus 1. N is equal to minus 1, del t plus 1. N is equal to 2, del t minus 2. And so on. Train of impulses, impulse train we are going to get. Train of impulses. Now from this you can say what is the fundamental period? 1 second. Or this one also. Look here, if you are unable to put your signal in the sinusoids or complex exponential form, already we have seen from the shape of the signal you can say. From the shape of the signal. Because we have ready-made expression for only for sinusoids or complex exponentials only. Suppose now I want the fundamental time period for this signal x of t. Minus 1 whole power k into del of t minus k by 2000. Come on, type your answers. See, the only alternative, it is not in the sinusoids or complex exponentials. Means draw the signal. How to draw the signal? Here k, where is the value of k from minus infinite to plus infinite? Give different integer values of k. Summation is there means integer values you have to substitute. What happens if I substitute k is equal to 0? Del of t. K is equal to 1. Minus del of t minus 1 by 2000. 1 by 2000. K is equal to 2. 2 by 2000. K is equal to minus 1. Minus 1 by 2000. Minus k is equal to minus 2. Minus 2 by 2000. Now can I say it as a periodic signal? Yes. It is repeating, no? At regular intervals of time. What is the period? T is equal to 1 by 2 by 2000 or 1 by 1000 is the period. If you are unable to put your signal in sinusoids or complex exponential, the only alternative what we have is to draw the signal. No other alternative. Right? Suppose if I ask you for this. So I think you are comfortable. Xt is equal to some sine square of 3 pi t. Sine square of 3 pi t is there. Now what is the fundamental period? Come on, tell me. Type your answers. Yes, Harish, you are right. Vamsi Krishna, you are also right. There is no heat in the chat box here. Tomorrow we are going to discuss very, very important concepts. I'm pretty much confident that given any problem from the first unit, you people can solve any question, or at least you will get some idea how to solve. Sine square of 3 pi t. How can you write sine square? Can I write it as 1 minus cos 6 pi t divided by 2? I can write, or 1 by 2 minus 1 by 2 cos 6 pi t. Right? Here DC is there. Does DC has any effect? No effect. Here reversal is there. reversal, amplitude scaling, does it has any effect? No. Reversal, no effect. T is equal to 2 pi by hope everybody got the same answer. Yes, Manu. Yes, Manu. So in this way, you are going to find out the fundamental period for different kind of periodic signals. So you can add one more point also here, amplitude shifting, amplitude reversal, amplitude scaling also you can write. Amplitude scaling also you can write. So amplitude reversal is also special case of amplitude scaling only. But if you put one more point also, no issues, amplitude scaling. So this is all for today's class. And tomorrow, my dear students, we are going to discuss what happens if we are given linear combination of signals like cos 60 pi t plus sin 50 pi t is given. How to find out the fundamental period. And after this, we'll turn our attention to the next topic, that is how to find out the fundamental period of a discrete time periodic signal. Discrete time periodic signal. First of all, what is the difference between fundamental period of a continuous time signal and fundamental period of a discrete time signal, we'll see. And after that, we'll see how to find out the fundamental period. And after that, if time permits, we can switch to the next unit. Not the next unit, next topic. So before leaving, you can follow me on unacademy.com at kvswami. Okay, those, see, there is no, see, I mean, many, you must give your attendance by pressing the like button, my dear students. Otherwise, you are considered to be absent. Type your attendance by pressing the like button. Property of signals. Okay, these are the variable channels we are having in Unacademy. This is our channel, mechanical channel. This is a chemical and civil channel, computer science channel, gate questions. This is also computer science, Unacademy gate English, electrical junction, and Apti Express. So these are the variable channels what we are having. And finally, thank you, my dear students. Ramula Vamsi Krishna, will you explain like stability and linearity? Linearity and stability will come in the unit called systems, properties of systems. Linearity will explain time invariance, will explain causality, stability, invertibility, everything will explain. Vamsi Krishna in detail. In detail. The only thing is you must share the sessions. You must like the sessions. Those who are coming new, I suggest all of you to subscribe also. Right. Okay, my dear students. Thank you.